Hey guys, today we're going to be talking about continuing our conversation about solutions, specifically homogeneous aqueous solutions. Remember, that means that they are dissolved in water. They are the same throughout, um, and the particles are small enough to pass through a filter. What we're going to be looking at today is what happens once the solute dissolves. So we're going to be looking at the nature of the solute, whether it dissolves, whether it forms an electrolyte, or whether instead it forms a non-electrolyte and what that means. We're also going to be looking at how the solute dissolves, which is based on the temperature of the solvent. So we know already probably that warm things dissolve faster, or things dissolve faster in warm water than they do in cold water. And so we're going to be kind of looking at this temperature specific behavior that happens in some solutions. So we're going to start by looking at the nature of the solute. So what happens when we have a solution, when we're making a solution, is that one thing that could happen is that the solute doesn't dissolve. Imagine that you took a bunch of aquarium rocks, aquarium marbles, and put them at the bottom of the water. And you stir and stir and stir and stir, and of course, it will not dissolve. They are made to be submerged in water and stay rocks. But other things do dissolve. And so something like salt, when you stir that into water, would dissolve. Things like sugar would dissolve. And once they have dissolved, they either form something called an electrolyte or they don't. And so that's really going to be the first thing that we're going to be talking about today. So electrolytes are products, results of the process of dissolving that conduct electricity. And so we need to talk just a little bit about that. When an ionic solid dissolves in water, the positive and negative ions separate from each other and become free to move around. And so what we mean by that is that when we put an ionic compound into water, an example of an ionic compound that we should be familiar with is something like NaCl, so sodium chloride or table salt, okay, your usual everyday run-of-the-mill salt. When you put this in with water, what's going to happen is that the water molecules, remember we talked about the process of solution, the water molecules are going to orient their way to pick up the sodiums and to pick up the chlorines and to pull them away from one another. So our solution is going to end up with Na plus compounds and Cl minus compounds, all dissolved in water, aqueous. Okay, so when we put salt in water, we make an aqueous salt solution. Now, these two ions, with their charges, are going to allow for electricity to move through them. So we call these things electrolytes. Okay, these are the electrolytes. And we know, you probably know, that electrolytes are important for your muscle function. In our neurons, we use sodium and potassium in order to help move or depolarize our neuron and keep our muscles firing. So if you get a muscle cramp, they might tell you, oh, well, you need to have more potassium, which is just an ion, right? K plus potassium. That's potassium. Or you might need more magnesium or any number of other electrolytes that you get from the food that you eat. They dissolve into your blood, the solution of your blood, and then they work in your body to help you conduct electrical current, depolarizing your neurons. So as we are studying these, this is what we just looked at on the board. NaCl is going to break apart into sodium and chlorine. And at this point, once it has, those electrons can now, or those ions can now piggyback electrons through the solution, allowing electricity to flow. And what I always picture in a situation like this is actually like some kids on the monkey bars, right? Imagine those electrons kind of swinging from one, electrons are negative, swinging from one positive charge to the next across the solution, and so thereby allowing the dissolved ions to conduct electricity. These ionic solutes, so once we are dissolved, remember we're called the solute, that's the part that's dissolved in water. These ionic solutes are called electrolytes, and they can be either strong or weak. Gatorade uses electrolytes to help our body. If you are a good athlete, if you work in endurance athletics, you know that just water replacement enough is not going to keep your muscles firing. If you start to work out, if you're going through a double day or going through training, eventually your muscles are going to start to fatigue and to cramp. And one of the ways to fix that is actually to have a lot of salt, a lot of ions in your in what you're drinking. And so that's what Gatorade and Powerade really are. And we're going to look at that in just a second. These ionic compounds that dissolve in solution and become electrolytes can be either strong, and so we call something a strong electrolyte when we can count on it dissolving, when almost 100% of the time it goes ahead and dissolves, or we can talk about weak electrolytes, and a weak electrolytes have a situation where it sometimes dissolves and sometimes doesn't. You pause what I'm doing. I'm going to be watching this commercial from Gatorade that talks about the importance of electrolytes and athletics. So go ahead and just watch along with me. A quick video that explains kind of the importance of electrolytes in our bodies. Gatorade is basically just salt water, and I have run a marathon before, and when I did, I was a little bit surprised to see that there are fueling stations along the way where obviously they give out water, but at first aid, they actually just have those little salt packets like the ones that you would get from a fast food restaurant. Because so much of the time when you're sweating that much as you're running a marathon, as you continue to sweat and sweat, you've lost so much salt that your body actually stops working. And so what you need to do is actually take the salt, and you would like put the salt itself on your tongue, and that would be a way to kind of increase your electrolyte production or your electrolytes in your body. Pretty strange to think that Gatorade then just takes that salt and then it adds a whole bunch more sugar to it in order to make the Gatorade taste good, right? Because otherwise it just tastes pretty bad. So these are, we're going to go past that one now, and on to this. So we have talked now about the nature of the solvent. So when we add a solute to a solvent, the solvent either doesn't dissolve, is insoluble, dissolves and it forms electrolytes, or it can dissolve and form a non-electrolyte. So that would be something that does not conduct electricity, like sugar is a non-electrolyte. So it can dissolve, but it doesn't form these little positive and negative ions. The material that dissolves just remains neutral. A way to affect the temperature of or a way to affect the rate of solution is by affecting the temperature of the solvent, and we will continue with that in our next video.